Well, it's good to be with you this morning, and we've got a good crowd here, and appreciate your attendance. I don't think we've ever had, this many people at the beginning of the program as we have this morning. It looks like, as I've counted several times, pretty close to 100 people in the room, so that's good. Merlin, we got enough food for them? All right, good. Well, it's okay. Forward here. Okay. All right. I was asked to address this subject of use of distillers' grains in swine diets, and does it impact some of the things we've heard about processing, as well as eating quality, which we don't know a lot about, or which we didn't until just a couple of years ago. And so I've worked with Greg Renfro on a project. Greg is our meats specialist, and we've got some data we want to share with you this morning. We've already had a pretty good introduction to the ethanol industry with our previous speaker, and so I think we can just bypass this slide. But certainly large amounts of byproducts are now readily available as ingredients for livestock and poultry, and it does have an economic value as a replacement for a portion of the more expensive corn and soybean meal and swine diets. However, there are some issues that need to be addressed. For instance, how much can we use in swine diets without reducing performance and carcass quality? Does feeding large amounts of DDGS, which contains 8 to 10% of fat that's pretty highly unsaturated, and as you know, pigs tend to deposit the kind of fat that they consume. So does this cause oily, soft carcasses that are frowned on, particularly by the packing industry? They do discriminate against carcasses from hogs fed such diets because the bellies tend to be softer, and they claim that they're more difficult to slice into bacon. And more highly unsaturated fats also tend to be more susceptible to oxidation. So what do we know about shelf life and eating quality of pork? Is it negatively affected by feeding large amounts of distillers' grains? So we had a group of swine nutritionists mainly in the Midwest that attempted to address this situation, particularly the first two. And I want to just briefly run over that this morning. I talked about this actually 2 years ago. The North Central Coordinating Committee, formerly called the NCR 42 Committee, followed a carefully designed experimental protocol to evaluate 4 levels of DDGS in corn soy diets for pigs throughout the grow and finishing period: 0, 15, 30, and 45%. We had about 560 pigs in the study, started at 33 kilos up to market weight. Looked at carcass traits, belly firmness, fatty acid composition, and a paper just has been published in the last issue of the Journal Animal Science, September issue, in case you want to see more details on that particular experiment. There are 9 different stations that participated. You can see the stations here, as well as the scientists that were involved in that study. Diets were corn soy control diet without any DDGS, and then 15, 30, and 45. And the soybean meal was reduced, and of course the corn reduced with the addition of DDGS. We used amino acid supplementation. We didn't need any dical phosphate in the diet with the highest level because of the source of highly available phosphorus there. All the diets, this just happens to be the finisher diet. We fed it in 3 stages. This was the final stage, and we balanced the diets on the basis of standardized digestible lysine. You can see they're all the same in those diets. And then just to briefly run through the results of that study, performance-wise, with the the 4 levels of DDGS here, you see there was no reduction at all. With that first level, we got a little reduction with the higher levels, but not very much at all. Feed efficiency was pretty much similar across the board. There was a linear reduction in growth rate, but it was very small, actually. In terms of carcass data, dressing percent was not affected here in this study. Back fat was reduced a little. Total amount of fat-free lean was linearly affected. Actually, it went up with the higher levels of DDGS. So that addressed the performance issues. We also ask all those stations to measure belly firmness with an apparatus such as this, very easily built piece of PVC pipe here where the belly could be laid over top of that pipe, and then it would hang down at something like this, and we measured the flex. The vertical flex is the distance from the top of the pipe down to the lower part of the belly, and the lateral is the distance from the center of that pipe it was hanging on. And so that was done, and as you can see here, there was a highly significant linear trend in both flexes. This one increased, this one decreased, meaning that those bellies were more flexible and softer as the level of DDGS increased in the diet. The fatty acids, the polyunsaturated fatty acids, you see, went up quite extensively with the increased level of DDGS in the diet, whereas the saturated and the monounsaturated went down. All of these were highly significant. Linoleic acid is the primary one of the polyunsaturated that's affected by the higher levels of DDGS. Of course, because of the linoleic acid, the polyunsaturates that are in the DDGS, because it's this was a corn-based DDGS. As a result, the iodine values increased from, I think the pointer's working, from 65 up to approximately 84 with that highest level of DDGS. Thank you, Merle. This isn't working either. I turned it off, you said? Oh, sorry. That ag ed degree does things to you. All right. All right, here we go. Well, iodine values, remember, this is just a measure of how unsaturated the fat is. It's a test that quantifies the amount of iodine that binds the double bonds of the fatty acids in a triglyceride, and but it can also be calculated from the fatty acid composition. And then the next question is, what's acceptable in carcass fat? MPPC back in 2000 suggested somewhere around 70. Boyd in 97 said that 74 was acceptable for pigs on a corn-soy diet. Some packers now have set acceptable thresholds at around 72 to 74, somewhere in this range. And so if we're talking about that, and then if we look at the levels then that resulted of iodine values resulted from the 4 levels of DDGS, you can see somewhere up in here would be the 70 to 74 range. So this level of 30% was slightly above that, and of course the 45 was definitely above it. So this would be the line for 74, and you can see that we're just a little bit above it there. This actually shows all 9 of those stations with the 4 levels of DDGS and the increase in iodine value as a result of increasing the distillers and its effect on the iodine value. And so with that said, we set 74 as the maximum that's acceptable. About 22% DDGS then, at least in this experiment, was the maximum that could be included without exceeding the 74. It's also important to look at this regression equation. It has a very relatively high R-squared value, 0.91, so it fits fairly well. And basically what it means, at least in this study with a corn-soy diet, we're hitting somewhere around 65 IV. And then for every 1% addition of DDGS in the diet, it's increasing the iodine value by about 0.43 units. Or in other words, a 10% addition, every 10% increases the iodine value about 4.32. That's going to vary from station to, or from experiment to experiment, but at least in this large study, this is the relationship between the two. Well, does that really cause a problem? We're hearing that it does. After curing and smoking, our soft belly is really more difficult to slice. Is that slicing efficiency, which is the percent of the marketable bacon that's recovered from slicing a cured belly, is it reduced? Are bacon slices less firm, and do they hold their shape when separated? When you open them up, open a package of bacon up and separate the pieces, do they stay firm? Do they stretch way out? You've seen some bacon like that. Is there more curling of the bacon during the frying process? Is bacon and other processed pork having more polyunsaturated fats more vulnerable to oxidative damage, resulting in more off flavor, shorter shelf life? Well, these are questions that we really haven't had awfully good information on. And as a result of that, we took the pigs that were in the Kentucky part of the study. There were 15 pigs per treatment, 3 reps of 5 pigs, and we followed those up to determine the processing characteristics of the bellies, and to follow that up also with sensory evaluation of the bacon, and also from sausage and pork chops as well. And so let me run through those procedures. We skinned, boxed, and transported the bellies to a commercial facility in Missouri, Burger Smokehouse. They were pumped with a commercial brine and then allowed to drain. They were smoked, processed, chilled overnight. Next morning we pressed them, or the company did. Then they sliced them with a high-speed slicer. I don't know if any of you have been in a bacon plant where they've done that, but that's quite an apparatus that slices that bacon. Slab just zips right through there with a high-speed knife, about 9 slices per inch. We collected all of that, and then after removing the incomplete slices, the comb marks, and other defective slices, the remaining were deemed marketable as bacon and were weighed to determine the slicing yield. So what we mean by slicing yield here is the weight of the marketable bacon divided by the weight of the smoked belly. That's variable, extremely variable from belly to belly. And this is what we've heard from the industry that's reduced with these softer bellies. They just can't get a good slicing yield out of them. Well, basically, here's what we found. There's the weights of the bellies. These data are all in the proceedings, but look at the slicing yield: 73.5, 72.8, 78, 73. It really wasn't reduced at all with the softer bellies. We were a bit surprised at that, but that's the way the data looked. We also did further evaluation by taking representative slices to determine shatter, how the quality of the fat in the bacon itself. Then we looked at distortion scores when the bacon was fried, did a taste panel work, sensory evaluation. We also did the same thing with the butts and shoulders that were used to prepare a bratwurst-style sausage, and determined color scores and T-bar scores over a 7-day period, and then did taste panel work with that, and also did loin chops with those same samples. This is the shatter score. This would give a value of 1 with a good quality bacon. It holds together very nicely, and then as you proceed on down the line, you see a 6 score is tearing of that fat content and get a kind of a spider web characteristic, and so you've got progressive numbers from 1 to 6, and so all representative number of bacon slices were scored that way. The distortion score, 1 a nice flat piece of bacon, and 5 being curled, severely curled, and then 4, 3, 2, 1. You can see the score going from 1 to 5 there. So when this was done, shatter score of the fresh slices, 1 through 6, actually that was significantly affected, and it actually improved with the higher levels of DDGS. The little softer bellies actually had better shatter scores. Distortion score of the fried bacon, not significantly affected, but again in favor. Let's see, the higher score would be on this end, so it decreased slightly with the higher levels of DDGS in the diet. In terms of texture and off flavor, no differences at all among those. These were scored from 0 to 15. The higher score would be more tender and more off flavor, but no difference in those as well. The sausage, the T-bars would be a representation of the amount of oxidation that's taken place. You've got more fatty, polyunsaturated fatty acids. You're going to tend to have more oxidation with storage, and that did happen. With the higher levels, those scores went up a little bit, particularly at this highest level, and that's a linear trend as well. So we're seeing a little bit more of that. Taste panel scores, there were some differences there, but the higher scores meant a little harder and chewier. So there's some actually a little more tender bacon with the higher DDGS level. Juiciness, the higher scores mean a little more juicy, and you see actually that went up. So that was in favor of the softer style bacon. And off flavor, higher scores meant more off flavor. A little bit increase there. It wasn't significant, and certainly we're within the range of 0 to 15. We're well below what you would call any off flavor at all. So it all tasted pretty good. Loin chops, no differences here at all, and you can see they were very similar. Again, 0 to 15, they were right in the median there. So that was the study that we followed up on the NCCC 42 study. We followed that up with another then study that involved withdrawal of DDGS from the diet during late finishing to see if we can improve at least some of the performance and some of the belly firmness problems, the iodine values. And we used 168 pigs in that study, 6 reps of 3 to 5 pigs per pen. We took that highest level of DDGS, the 45%, and fed it all the way with a corn soy diet, or we withdrew it the final 2 weeks or 4 weeks or 6 weeks of the study, and then those pigs went on a corn soy diet right after that. We actually had 2 other treatments. I'm not going to spend any time on that this morning, but we added 5% of a very hard fat, beef tallow, to see if we could, by adding a little more saturated fat, if we could bring bring those carcass changes to the point where they would come back to a more normal type fatty acid pattern and firmness and so forth. Performance-wise, we got a little more reduction with it, with the high level of DDGS here, but by withdrawing it the last 2 weeks, 4 weeks, and 6 weeks, we were able to bring that up to where there was just a 4 or 5% reduction in growth rate. Feed efficiency was not affected at all by those various withdrawal periods. Here's the DDGS with no withdrawal, 2 weeks, 4 weeks, or 6 weeks. In terms of carcass data, a little difficult to get all these pigs killed at the same weight, so we've got a little lighter pigs here because they did grow a little slower. But you can see some differences there between the corn soy and the DDGS. And then as we withdrew it, some of those changes went back to levels that were fairly close to the corn soy. Overall here, we did see a little reduction in dressing percent in this study. This was based on 6 replications of 3 to 5 pigs per pen. Some other changes in back fat and in carcass lean, and again, those were moderated some with the withdrawal scheme that we used. We looked at belly flex. Now remember, this is lateral, so this would be the corn soy diet. This is the softer carcass because that lateral flex is a lot less. But then you can see with the withdrawal over 2, 4, or 6 weeks, we brought those belly firmness scores right back up to the corn soy. This was the vertical flex, and it goes just in the opposite direction. So here's the straight DDGS, and then as we increase the withdrawal period up to 2, 4, 6 weeks, it brought those vertical values down to our corn soy control. Fatty acids in the fat. The red is or the yellow is the polyunsaturated fats, and again, as you'd expect, the DDGS, high level of DDGS. We went from about 12% up to about 25%, but then by withdrawing it, we progressively reduced the amount of polyunsaturated fatty acids in those fat stores. The monounsaturateds and the saturateds followed just that opposite pattern. So we were successful. We felt successful with that kind of withdrawal scheme. Iodine values, 60 in our control up to 78% or so, and then by withdrawing we brought this down to about 74, which is kind of our max, with 4-week withdrawal down to 70, and then down to 67 with the 6-week withdrawal. Now this was the iodine value of the back fat, taking both the inner and the outer back fat. We also looked at belly fat and jowl fat, and they were fairly close to the same as the average of the inner and outer back fat, which is the inner and outer back fat. Slicing yield, again, same thing as we saw in that first study. With the DDGS, there really wasn't any difference, very small difference. None of them significant. This increased a little bit with the withdrawal, but pretty much the same across the board. Shatter scores, some trends there, a little less shattering here with the DDGS, so a little softer bacon, and the shatter scores were less, indicating a little higher quality. Distortion scores were scored a little bit higher though, so they're a little more curling, and withdrawal didn't help that much, a little bit, but not that much. None of those were significant. And same way with taste panel, no difference in off flavor or texture between any of those treatments. We did T-bars. Again, this is a measure of the oxidation of the fat, an indication of shelf life. This is the 7-day T-bars. We just did that on the loins in this particular experiment. So with the higher level of DDGS, actually the T-bar scores were lower. And with withdrawal, well, they tended to increase some. So there wasn't any problem at all here with this level that we were feeding with no withdrawal. Taste panel scores. Again, you can see some differences there that are very small, but again, they're all within a range being pretty much normal. I think there's an error in the proceedings here. These scores were 1 to 8. There may be another table that I had the range incorrect. Just to touch on the tallow to show that it wasn't really effective at all. Daily gain it did bring. This is corn soy now with tallow, without and with tallow. This was our DDGS diet, the high level without and with tallow. So that reduction that we got with DDGS, reduction in gain, we were able to bring it up pretty much to our control when we added tallow back to the diet. Dressing percent, that came back pretty close to the control as well. But as far as the polyunsaturated fatty acids, didn't help that much, reduced it just a little bit. Iodine values, they stayed the same. And the other data, some of the bacon data and the loin data, is shown there, and it really didn't affect those that much either. So we felt from this that the tallow just really wasn't effective at all in improving some of the problems that we have with the softer carcasses when the high level of DDGS is fed. To kind of wrap things up, this idea, this thought that the iodine value does cause some problems with slicing efficiency, these data don't bear that out, in either one of these two experiments. And in fact, we took the data from both of those experiments and plotted the iodine value of the individual bacons, the individual bellies, against the slicing yield of those individual bellies. And it looks like a nice shotgun pattern there, just all over the place. A lot of variation you see, some above 90%, some as low as in the low 30s. But there just doesn't seem to be any relationship at all. And the regression equation is almost completely flat there, and the R square is very low as well. So it just doesn't look like there's a problem with that at all. Economics, this is at $7.25 corn, soybean meal, cost of lysine. If we say maybe a 2% or so reduction in yield, 2% reduction in feed efficiency, today's cost of DDGS is what, about $205, $10 a ton. It's quite a bit more than it was a couple years ago when we talked about this, but if you put that in a little program, it says that the value of that DDGS is about $265 a ton. So if you can buy it for $200 or so a ton, it's still a very economical ingredient to use. So to wrap it up, feeding of high levels of a high quality DDGS does not have major effects on growth or carcass traits of grown finishing pigs when diets are formulated on an SID lysine basis, and amino acids are used in order to reduce or to avoid the excessively high protein levels. They do result in more polyunsaturated fatty acids in the carcass fats, higher iodine levels, and so forth, and softer, more flexible bellies. And withdrawal of DDGS in the late finishing diet restores some of that belly firmness and improves the fatty acid composition to a certain degree. Tallow is ineffective in terms of helping the situation there. And some of the processing characteristics, the shelf life, eating quality of bacon, sausage, and loin chops, at least according to our data, is not affected as much by softer carcasses as we once thought or have been claimed to be in the past. I'd like to acknowledge the National Pork Board that supported this research with 3 different grants. ADM Alliance Nutrition provided the DDGS for us and amino acids for the study. And in particular, Caitlin McClellan and Miranda Ulrey. Miranda's here, I think. There you go. Stand up, Miranda. Let them see. She's the one that did all the work on the study and made the rest of us look good, I guess. Caitlin's not here. She's working on a PhD up at the University of Minnesota. Miranda's an extension agent here for Purdue in Indiana. But they did their master's work with the sensory evaluation and all the bacon data for this study. So that wraps it up. Brian, I'd be glad to